we're going to take a look at another skill from algebra that's going to be useful for us moving forward, and that skill is working with proportions. So, proportions are things that help us kind of relate values together. And so the first thing that we should probably talk about first is what is the difference between a ratio versus a proportion. So a ratio is just a comparison between two numbers, and so commonly we'll see this as 1 to 3, or maybe even written out 1, 2, 3, or maybe most commonly we'll just see this as a fraction, 1 over 3. So that is a ratio, comparison of two numbers. Versus a proportion, on the other hand, is whenever I'm comparing two ratios. So for example, I can say 1 is to 3 in the same way that 2 is to 6. So that is the difference between a ratio and proportion. Proportions have these equalities in them, as opposed to ratios are just the comparison of two numbers to each other. So what does this look like if I want to solve some problems using proportions? Because since I have an equation, that means that I can set something up algebraically to solve. So let's just look at a really basic example here that you could probably solve in your head, but we're going to kind of work out. And so what if I have the proportion that 3 over 4 is equal to some number over 8? So one way of thinking about this is that I'm thinking about the comparison of these numbers. 3 is to 4 in the same way that something is to 8. And so we can see that, well, 8 is just double what 4 is, and so x is just going to be double what 3 is, because they have that same ratio within this proportion. And so we know that x is going to be 6. But let's say that we didn't see that right away and we needed to solve it. How would we do that? And so I think the thing that's going to come to most of our minds is the term cross multiply. But what I really don't like about cross multiplication is this, not implication, but this idea that it's just kind of like magic. It just works. And so the question is, why does it work the way that it does? Well, what I'm going to do is I'm going to solve this equation, but without cross multiplication. I'm going to think about this as, I don't want to necessarily deal with fractions here. It might just be easier for me if I don't have any fractions to work with at all. So what would I need to multiply the left-hand side by so that these are no longer fractions? And the answer is I need to multiply by 4. And what do I need to multiply the right-hand side by so that there are no fractions? And that would be 8. So if I multiplied both sets of fractions by 4 and by 8, what I would have is, so multiply by 4 on one side, 4 times 3 over 4, and that's going to be equal to, and then 4 times x over 8. And then I'm not going to simplify this yet, so just give me a second. I'm also going to multiply by 8 then, so I will have 4 times 3 times 8 over 4. I understand this is a very complicated way of writing all this out, but it'll make sense here hopefully in a second. 4 times 8 times x all over 8. And so what ratios are these fractions, and what that really is just division. So when I divide by 4, what I just get is 1. And then divide 8 by 8, I just get 1. And so what I'm left with is 3 times 8 is equal to 4 times x. And so what cross multiplication is, really what it is just multiplying by both denominators. When I multiply both sides by the denominators of my two fractions, each side is going to have one of them divide out. One will be left with just this product, which looks like cross multiplication. And so then I can divide by 4 here and get that x is 6. So how can I do this with something that's a little bit more interesting? So let's say I have a problem like 3 is to x minus 1 in the same way that 6 is to x squared minus x. And we're going to talk about a potential issue that could come up here. So to solve this, what I'm going to do is apply my cross multiplication here. And so what I will get is that 3 times x squared minus x will be equal to 6 times x minus 1. when I multiply all this out, I will get 3x squared minus 3x is equal to 6x minus 6. I'll collect all my terms on one side, and I will have that 3x squared minus 9x plus 6 is equal to 0. So I'm going to have to factor this, but before I do that, I might as well just divide everything by 3 to simplify this for me. And what I will have is x squared minus 3x plus 2 is equal to 0. So then this I can factor. So what does this factor into? Well, I need two numbers that multiply to be 2, positive 2, and then add to be negative 3. And so what those numbers would be negative 2 and negative 1. So what I have is x minus 2 times x minus 1 is equal to 0. And so when I solve this, that means that either x minus 2 has to be equal to 0 or x minus 1 has to be 0. So that means that x is either equal to 2 or x is equal to 1. Now here's what I really have to be careful of. And this won't show up every time, but only kind of in these more complex problems. But do both of these satisfy the situation that I'm given? Because a lot of times whenever I'm setting up proportions, proportions mean something in context. So for example, if I'm setting up the ratios of lengths or the ratios of, apples and bananas or whatever it may be, and so I need to plug these back in to see if they make sense. And when I do that, when I plug in 2, what I get is, so when I plug in 2, I'll get that 3 over 2 minus 1, that's 1, is equal to 6 over, 2 squared, which is 4 minus 2 is 2. So 3 over 1 is equal to 6 over 2. That checks out. That's no problem. If I plug in 1 on the other hand, what I will get is that 3 over 1 minus 1, which is 0, is equal to, and then 6 over 1 minus 1 again, which is 0. This is no good. All right, I cannot divide by 0 here. And so whenever I'm dealing with proportions, I just need to be careful that the values that I have solved for, the values that I've gotten out, actually fit the system that I initially had at the beginning. And so I should always go back and check my work. And so my answer here is actually just the x equals 2 value here. So to sum this all up, we talked about the difference between ratios and proportions. Ratios are just a relationship between two numbers, while proportion is a comparison of two ratios using the equals, not operator, but the, I want to say equal sign. We'll just say equals. And then when I solve them, I can use cross multiplication here, but we know that's just really just multiplying by my two denominators. And then when I do solve these, what I should always do is plug them back into check to make sure they actually fit the situation that I'm working with. So proportions are a great tool that we have from algebra that are going to help us out moving forward.